Hi folks, today we're going to take a look at what would happen to Mars if Comet ISON had the mass of a planet instead of a normal negligible cometary type mass. Now Jim McCanny is claiming that ISON is in fact quite massive and that it has multiple companions that are following it up to 2 lunar distances or so, and that therefore it must be a massive object, possibly as big as Earth or maybe even bigger. And if that's the case, it begs the question, what would happen to Mars? Because later this year, Comet ISON is going to be going right by Mars at a distance of only 0.072 astronomical units on October 1st, 2013. Now, this is not to be confused with Comet Spring, which will be making an even closer pass in 2014 and might possibly hit the planet. We can't rule that possibility out yet. And I've got another video on that. That's a whole nother story. But ISON is also going to be making a close pass of Mars, only happening this year in October. And as such, if it is a massive planet as big as Earth or bigger, it begs the question, would we see some change in the orbit and position of Mars as a result? Or would it be too small for us to detect with amateur equipment? So to answer this question, I did a couple integrations using ORSA. In one integration, I had the normal solar system and ISON with a 0 Earth mass, and integrated it for a 1-year period in 1-hour intervals, and produced a text file filled with orbital elements for Mars. And in the second integration, I had ISON with a mass of 1 Earth, and integrated over the same period at the same 1-hour intervals, and generated a second text file with orbital elements. Now in both of these integrations I had all the planets of the solar system included, so all the gravity of the planets is included in these calculations, and as such the orbital elements in both will change over time under the influence of the planets, but they will change differently, because in one simulation you have a comet approaching Mars with the mass of Earth, and in another you have a comet approaching Mars with negligible mass. And as you can see, the first line of the orbital elements is the same for both. They start out with the exact same conditions and diverge over time. Now I will provide these text files as links in the video description. You can download them and take a look for yourself. But I've gone ahead and loaded orbital elements from these files into Stellarium. I'll just lay out how these orbital elements are organized so you can see and use them as however you like. The numbers are laid out as such. The first number is time. This is time in days or fractions of a day, and the first day listed is March 26, 2013 at midnight Universal Time. The second number is the semi-major axis in astronomical units. The third number is eccentricity. The fourth number is inclination in degrees. The fifth number is the ascending node. The sixth number is the argument of the pericenter, and the final number is the mean anomaly. So that will give you everything you need to calculate the position of Mars for any given point in time. And normally, if you're not already aware, orbital elements, again, will change over time for any of the planets. They're not fixed because the gravity of the planets will influence each other and actually change the Keplerian elements over time. So you can't just load in orbital elements at point 0 and expect it to accurately show you where Mars will be 100 days later. So these files actually have the orbital elements for all points in time at 1-hour intervals for a 1-year period. I've gone ahead and again loaded orbital elements from late October into Stellarium from both of those files, and first of all we can see that the orbital elements that correspond to the simulation where ISON was given negligible mass match with the position predicted for Mars according to Stellarium. In fact, it's a perfect match. You can see up here the right ascension and declination, and if I then switch over to Mars and select Mars, you'll see those numbers don't change. So we have a good confirmation that ORSA is in perfect agreement with Stellarium. Our negative control is normal. It's all good there. But if we select the orbital elements that correspond to the simulation where ISON has the mass of Earth, we see a quite significant perturbation. This is at October 27th, 2013, and we can see that the orbital elements now give you coordinates that are different from the normal situation, the normal solar system, where ISON has negligible mass, and for that matter, Stellarium's predicted position for Mars as well. So we can see in declination we have 10 degrees, 26 minutes, 36.4 seconds, according to the simulation that had negligible mass for ISON, and in the simulation with ISON having Earth's mass, it is now 10 degrees, 26 minutes, 39.3 arc seconds, so about 3 arc seconds difference from the normal predicted position for Mars. Now that doesn't seem like a whole lot, 3 arc seconds, but it is definitely measurable, even with amateur equipment. With my own telescope, my 8-inch Schmidt-Cassegrain, I have a theoretical limit of resolution of about half an arc second. So it's about 6 times that, and under normal conditions I normally operate at about 1.2 arc seconds per pixel resolution, so well above the limiting resolution of how I normally use the telescope. It would definitely require astrometry to detect, but not a big problem. That would definitely be noticeable for sure. So if McCanny is right, we should see a noticeable change in the orbit of Mars come this October. And I'll definitely take a look. I'll definitely measure Mars' position and see if a change is seen. I seriously doubt it, but hey, we'll put it to the test. So there you go. There's the prediction for the future. If McCanny's right, we should see a change in Mars, in the orbit of Mars, that corresponds to 3 arc seconds by the end of October 2013. Have a nice day.